All right, ladies and gentlemen, we have a request for doing Fall 19, Test 4, Part 4, Question 3. I want a mechanism for each step below. So what's happening in the first step is we're losing an OH off of this carbon and an H off of this carbon. That's called dehydration. Acid catalyzed dehydration. The first step is to do, well, they're all acid catalyzed dehydration. Nothing but here. And this one, the ring grew. Oh, interesting. All right, so what's the first step for reactions of a lot of alcohols where there's an acid present? The first step is to protonate the OH to make it into a better leaving group. It's going to leave as water now. Not just yet, but pretty darn soon. So this one's not that hard to draw. Yeah, we can live with this one.
Can we do the R thing?
R's tricky because they like over here. We had a suggestion to do the R thing, and I'm going to try my best. I think the best I can do would be something like this. Well, you need the next carbon over too, because something's going to happen there. So if we go like this and circle everything except for the, I'm starting to like it. Because there's no change over here. Your point's well taken. So that bond has to stay, and then you can just do this. That's acceptable to me. That's pretty clear. There's the bond there, still there. And the R is everything not circled. There we go. And now, the question is, do you want to do an E1 or an E2? And with a secondary or a tertiary, I hope you want to go with the E1. And it's a secondary RX, right? Secondary. So carbocation, I want to see. And I got a student right now saying, wait, I thought secondary was, I don't know. Yeah, I'm sorry. That H looked like it was bonded weird. Well, I like secondary cations in an environment where there's a strong acid present, because to me, strong acids are they're protic. It's a protic environment. Strong acids have H bonded to O, right? Well, in this case. So I want to go with the protic environment mechanism, which is carbocation. Water leaves, and you're almost there. You've got a cation at the top here. You've got your R and your R. And you got to know that this is the only H that matters right now. There's no H on this carbon up here. There is an H on the same carbon down here. What's going to take it is the sulfate ion you generated when you deprotonated sulfuric acid. Sulfate ion grabs H, sigma becomes pi, end of story to get to there. And the next one, I don't know. I don't think doing R is going to help us visualize the rearrangement. I'm just going to do the whole thing this time. Yeah. And lone pair on O, same story. Primary this time. Uh-oh. Uh-oh. I don't want to see a carbocation. Not on a primary carbon. So we got a 6. Got a 5, 6 again. We got this. Nice leaving group. And And you don't have the E choice for the carbocation, the E1. So your best option to get to that product is E2. And we're going to need our base. Oh, a red charge. Red's for my arrow. So yeah, here we go. No carbocation. You're going. Ooh, that arrow's kind of small. Can you see it?
Yeah.
I don't know. I still don't like it. You're being kind, I think. I just wanted to be very clear. I think if I had that H a little more vertical, I could make it look better. There we go. Grab that H. Sigma becomes pi. Oh, I like it better. There you go. And just a reminder, this method to the cation is an E1 method. And this method without going through the cation is the E2 method. A primary carbon cannot do a carbocation. So comments, primary Rx cannot make C plus, carbocation. So you got to go E2. Secondary and tertiary, they love it. This one was tertiary. Tertiary Rx goes to C plus. These are just kind of a notes on the side here. I don't know what happened there. Hello. There you go. Notes on. This carbon has only one bond to C.
Yeah, but the other one is secondary.
Oh, it's tertiary. Sorry. Yeah, thank you. I misspoke. It is secondary. Secondary carbon can make a cation, right? And now the dilemma is this last product, which must somehow come from the same start. Must somehow come from this. And you're not allowed to draw a primary carbocation as per my edict in class. So what are we going to do? If you did this, it would make a carbocation, right?
Yeah.
Well, as that starts to happen, the ring expands. Watch this. As that starts to happen, this bond goes over here. It doesn't matter. This thing would, same result both ways. She asked a good question, why not the bond on top? And I answered it would give a similar result. Both of these results could yield our product. I can prove it. So I changed to the one you suggested. And yeah, if if you're having trouble visualizing rearrangements, do what I try to do. Draw everything except the bond you broke in the same location it was before. So I didn't touch that. I didn't touch this or this or this or this. But I did make this bond over here, and now I have a cation right there. Why there? The CH2 is now bonded to this C, and the next carbon over doesn't have an octet anymore, this one. Going around, this is the one off the bridgehead, which is now connected over here with a red bond. The next carbon here, I didn't break this bond, but it doesn't have 4 bonds anymore. That's this one. And now you got to say, how can I make this into this? And you got to take an H from there. And what's going to take that H is our friend sulfate. And there you go. Now, I just want to prove what I said earlier. You don't have to show me the alternate mechanism where I break the other bonds, but I just wanted to show you that you can get the same result by breaking the other one instead. So instead, break this one. And it gives it looks different, but And it is a slightly different cation, I believe, but it also can lead us to our product. Yeah, I think. Maybe not. Let's see. All right, everything except the bond that broke. Everything except the bond that broke. And now that bond's up to here, and the cation is the second one off the ring, and I believe that can get us to our product too. The product. Notice it's a different cation than the one above. It's the second one off the ring. This one's the third cation, carbon off the ring. But goes to the same product if you do this. Same result. Result. If you get OSO3H. There. Okay, so big picture before we close it up. And there we have everything. Good stuff. Good warm up, I think. Save and we'll start. I think we had a request for question 4 next. Same test coming up.